Okay, so let's check if we have cleared everything. Everything is clean. Okay, kubectl get all, so everything is clean. Kubectl get namespace. Okay, we have some namespaces. I'll delete it. It won't interfere, but still let's delete it. Kubectl delete namespace. Test. It's taking some time. Test prod and day we will delete. Prod and delete. Oh, sorry, Dave. So kubectl get all, everything is clear. We by default check properly. This is the default configuration. So by default only we have default namespace, kube system, kube public and kube node release. Okay. So let's check what is there inside it. So kubectl get all will give the details of default namespace. So we have only a Kubernetes service running it, and -n. Let's check the kube system. So kube system has some pods running inside it. Okay, one is for networking, Calico is for networking. Okay, and the core DNS is for internal DNS. Okay, and one of the kube DNS internal service is running. Okay, so apart from that there is nothing much. This is also related to the networking. So apart from this, let's check kube get namespace. So kubectl-n node lease get all. We have nothing inside it. Okay, it varies from version to version, means maybe in some other Kubernetes it may have something, but as of now in this it is empty. So whatever we have is in kube system. So by default this is what installed when we install microkts. Now we want to install Ingress. Okay, so we know that when we install Ingress we used to check its status. So when we check its status, microkts status, so by default the core DNS is enabled. That's why we were able to see kube DNS there. Okay, then HA cluster is enabled but it is not installed. Availability is not there because we have as of now only single node. Helm is just the command. Okay, we will know about it later. It is just a kind of a package manager for Kubernetes. Apart from this, all other add-ons, okay, or you can say these are all third party. They do not come with along with the Kubernetes by default. Okay, so one of the add-on which will be enabling now is Ingress. So when I mean enabling, so let's first enable kubectl enable Ingress. So if you see what it is doing when I do enable, it is installing uh, some configurations are created. Okay, so what are these configurations? These are nothing but some YML files executed at the backend. So everything will be installed in this Kubernetes. Even some controller like Ingress or March730PM Ingress will be
Your voice, Rahul.
provided
Voice is getting
by
clear.
third party
Prag,
from
we
here.
lost your
Okay, so it is
Prag, we lost
en-
your voice.
now I'm audible.
Yeah, now it's fine.
Now audible.
Okay, so for how much time it was not audible?
Just 1 minute before, just you.
Okay,
After enabling it.
okay,
Just 10 seconds only. Okay.
okay, fine. So whenever we enable Ingress, what happens is at the back end it is downloading some YML files and installing it. So so maybe in production sometimes it will not be so easy to enable Ingress. You'll have to go to the website. Okay, Nginx controller. So there are various types of installation methods. Okay, then installing Ingress controller, installing using manifest, one of the options. So what we'll have to do is we'll have to download some YML files, okay, like this, and execute those YML files, and it will install the Ingress. But microcatus for learning purpose has made it very easy for us. It has already added some YML files. We just need to enable it. When we enable it, those YML files get executed. Okay, so whenever now again check microcatus status, and if you see, the ingress is enabled. And whenever we enable it, if you see kubectl get namespace, that's why I was stressing on namespace, we have an ingress. Okay, so if you go inside ingress -n ingress get all, we can see a pod is running. Okay, so nothing else is there. We'll be installing something in next exercise here, but the ingress is installed now. Next we'll be creating some configurations related to ingress. So we have checked namespace for ingress, resources in the ingress we are checking. Okay, now let's create a web directory, mkdir web, cd web. Inside that I will create some configurations, or in short we can say I'm creating two deployments, one called web app 1, other will be web app 2. So I think you remember, if I add this dash dash dash, it will be considered as the new file. So two YML files I'm just combining in one. So web app 1, it has a deployment with httpd image. Okay, and for that we have a cluster IP service. Similarly, let's create the other one, web app 2, with the deployment and service. Okay, so while copying, just make sure you are not copying the last line which I am removing now. Okay, otherwise it will not give an error. Okay, so we have two deployments and two services for it. Just to kubectl apply -f web app 1 and web app 2. Kubectl get all. So these are the two deployments are getting created. Okay, we have only one replica, and the services are already created. Now we have to create some routing rules. For that, we'll define an ingress, web ingress. So what we are doing here is, whenever request comes to web, okay, the rules which we are defining here as, whenever the request comes to web 1, it will be forward to web app 1 service, which we created here, web app 1 service. And whenever the request comes to web2.example.com, it will go to the second service, web app 2 service. Just to kubectl apply -f web ingress. Okay. Now kubectl get all will give the details of pod services and deployment, but it will not give for ingress. For ingress, we'll have to do kubectl get ingress. Okay, so if you see, web app 1 and web app 2, these are the two hosts behind this web ingress. So traffic will be coming to the ingress, and it will be based on the routing rules, it will be forwarded to this host. Okay, but if you see, the address it is showing is 127. That means this ingress is running on the local host only. Okay, though as I said, a microcatus is for means learning purpose. Okay, so as of now it will only we can only check the output on local host itself. Okay, so what we'll have to do is, inside /etc/host, okay, we'll make two entries, so that the host name gets resolved to the IP address. Okay, so I'll add these two entries. The first, the second one is already there if you see. So just remove this one. So what will happen is whenever the request comes to web1.example.com, it will come to the localhost. Similarly, web2. Ignore this one. Okay. So let's cross check what happens if we do cat/etc host ping. Whenever we make an entry, it should get resolved. Okay, the ping is working properly for web1 and web2. That means the entry is working properly. So instead of using DNS, as we do not have a DNS server here, we are just mapping the IP address to host name. And why I am mapping it to localhost? Because the ingress is running on localhost. Okay, 127. Now when I do curl web1.example.com, okay, it will work properly. Similarly, if I do curl web2.example, it will work properly. So what is happening is the request is coming to web1, and it sees that whenever the request comes to web1, it should forward it to this service web1 and web2. But as both are having the same kind of page, we are not noticing the difference. So for that, what we will do is kubectl exec-it execute an interactive terminal -it for this pod 1 and access its bash shell. We are connected to the bash shell. Go to cd htdocs. In htdocs we'll have this. What I'll do is just overwrite it. So this is web1 index.html. Okay, similarly let's go to the second one, but this is temporary. You know that after the pod restart it will get, but for testing purpose it's okay. And in the spot 2 I'll make the changes in index.html. Okay, cd htdocs. So this is the page which gets displayed. It works. So I'll just overwrite it using this command echo web2 index.html. Okay, just log out. Now when I do curl web1.example.com, it is giving web1, it is routing the request to web1, and web2, it is routing to web2. Okay. But for testing purpose, this is all working on the local host. Why? Because by default it is working on localhost. The ingress is working only on localhost. Okay, in next exercise we'll add the load balancer IP. Okay, the metal LB load balancer, and then we can access it from the outside world as well. Okay, so that's it for this exercise.